All right, folks, we are live now. So, hey, folks, this is me, Vishwas Nayan. I'm the host of the DevOps chat show. And a lot of times, when the industry leading experts come back to us, and you know what, there is a gap between who is the best of the best engineers, who is the best of the best of the best of the problem statements. Like, they might be solving some of the problem statements, which might be best of the best, but need not have of the best engineers. Over a course of time, there is a new need in which engineering problem statements have come up with. And I think Bhargava is one of the people who are extremely hardworking. Trust me, an amazing person who literally loves educating people as much as possible and a lot of things. So, Bhargava, thank you so much for being part of this show. Means a lot. Sharing your engineering insights. And this will help a lot of people in the future as well. So, thank you so much, Bhargava.
Thank you, Vishwas, for hosting me in.
Sure. Let's just come out with that one journey that we all have, right? Once we get in, we start as some support engineers, we start with the associate roles, then we evolve. So now I want to ask a question like, what's the impact that a support engineer could make on an industry? Like, how effective can we be as an engineer? Make sure that we have an impact in the industry.
Um, that's a good question. So, um, in in any industry, the impact that a support engineer could make is that uh, he could fill a knowledge gap to influence the purchase decision at a pre-sale stage. So he could fill a knowledge gap. A support engineer could fill a knowledge gap to troubleshoot an issue at a post-sales stage, or train the end users to get the best return on investment on a product or a service, or train the end users to self-help themselves, capture feedback from customers. So industry would differ. It could be fintech, it could be space, it could be edtech, it could be biotech, it could be a fashion industry, it could be a retail industry, it could be e-commerce industry. But in all these industries, there is a pre-sales and a post-sales stage. So so as an engineer, um, he has the he has a tremendous power to influence the end user's experience. Say that they were facing a let's take a fintech industry as an example. Since I've been from the fintech space, I started my journey from a fintech space as a support engineer. You went and applied for a loan application. Your loan got sanctioned and disbursed. So then you want to raise a you want to and you see that in any online loan application there will be different lines of credit. So you have utilized one of the line and there is another line that you want to utilize. This is a typical example of a business loan or SME loan. So you need to, based on your repayment history, you would either be eligible or ineligible to borrow again there. So let's say that there was you used a phone number or an email ID to while signing up for a loan application, and you say you forgot it, you don't remember it, or your phone was lost. So, but that phone number is like an ID, it's a primary key in the fintech in an applications in a fintech applications database. So when you come and again do a OTP or when you try to apply for a new credit again, then you need to supply that same phone number because that is used for one-time passwords and authentication. So I as an engineer will go and edit that or update your phone application either through APIs, or I will raise a ticket to service team to do that. So this is one of the use case where there isn't an automated approach or automated way, and I'm trying to fill a gap there to convert a lead to a sale there. Or there is a case where a civil pool was failing for you for the second time. So it's due to a mismatch in address or a phone number. Or your loan was sanctioned but disbursement failed because one of the partner banks were facing a trouble with their servers. So in these kind of cases that I I go and check the logs and see what's the problem. Then communicate with the stakeholders, internal teams and external teams. Then find it, then fix the issue. So in any industry, or a horizontal or a vertical, support engineers play a vital role, whether it's a technical or a functional support or operational support. They're vital for the product, technology, and the sales teams. Did it make sense?
Yeah, it's a very impactful role, right? Everybody needs to have that evolution. So everybody needs to know who runs the show, right? It's always about like who really has that entire culture that is getting evolved. So yeah, that's the part about it. So I wanted to know what are the pros and cons of working as a support engineer in the fintech space, as you have been addressing a lot about these kind of problem statement, right? So, what are the other face of that industry as well? So, how can we understand what's the pros and the cons, and what have you felt about that industry as one of the benchmarks for any person? Like when we start our journey, it's one of the benchmarks that we wanted to achieve. And so, what are some of the pros and the cons when you are working as a solution engineer in an fintech world?
So I worked as a support engineer. It was a product support specialist role, not as a solutions engineer. So so I can tell from that perspective. So the pros of working in a fintech space as a support engineer are, you will get to learn the tasks that happen in the background when you apply for a loan. So I worked for a non-banking financial corporation. Um, so it was not a bank, but it was similar to a bank, but which had partnership with several banks and institutional lenders. So as a borrower, loan borrower, when you go and apply for a loan, what are all the tasks that happen in a sequence of events that happen in the background that you get to know? um, you get to know the authority of fintech companies to make an entry in the CIBIL or Experian records. CIBIL and Experian are um, the authorities, are the financial are sort of a financial regulators who who have a record of uh, who have a record of the repayments of a borrower. So this data is shared across all the banks throughout the world. Experian is a European-based regulator, and CIBIL is an Indian-based regulator. Both have footholds in all over the all through all over the world. So they share data. So this is important because from a regulatory point of view and from a compliance point of view, so they need to share data among each other. So you also get to know the basics of borrowing or lending. So how does borrowing happen? How does lending happen? Because so you lend for a profit, so you don't want to make losses. But the way to make profit is really harder in this industry, because if you see the delinquency ratio of major lending institutions or banks, they're very skeptical about. Some banks are very skeptical and about lending it. They have a very conservative policy. But if you see certain NBFCs, they have at a higher rate, they have a higher risk appetite for lending. So you get to understand how does the borrowing or lending works at a very fundamental level. So then another important factor is that what are the data points considered for underwriting? Underwriting means if you had applied for a insurance or a loan application, something happens. Some there is a person called underwriter. He's also called as a credit manager at some companies. So he uses data science to evaluate lots of factors. Well, I had experience. It was like 21 data points were considered to consider if a borrower is a loan worthy individual. So one of the data point is like a age, then he's a politically exposed person or not, his location, his previous repayment records pulled from CIBIL and Experian, then his institution kind of business they do. So these are all put into a model, financial modeling. They do a modeling similar to machine learning, but coding, and based on this output, either gets to know yes or no decision there, and risk is also calculated based on this. So you get to experience the data science behind the science of underwriting a loan application. Then there is a you will be you will see who are the institutional lenders, the high net worthy individuals, and partnership with banks. How partnership work with banks. Institutional lenders could be major banks such as Axis or ICICI, HDFC. It could be Indus IND. These people have a huge pool of uh, cash with them, cash that is being deposited with them. Say there is thousands of crores of fixed deposits there, but they lack access to this borrowers' data. So they have partnerships with several NBFCs who are technologically advanced and are very deep rooted or grass rooted in lending to SMEs, mom and pop shops, retail borrowers there. So there is a percentage shared for service charge, and they get to share the profits and losses as well. So if loss happens, there is also a policy which dictates who gets to write off the losses on whose books, whose accounts. So you get to also see that, experience that, and you also get to know how banks share their customer data with each others. So in today's world, this is usually looked down upon, since banks have the least integrity while sharing the data. You get a lot of calls from who sell insurance products or credit cards. So it's not that. So banks have to share data with each other because it could be a phone number or email ID. It could also be your address, home address, because they all have their backs against each other. Because that's how the financial industry, fintech industry, is regulated. So a loss in one bank will affect another bank because they do settlements at the end of the day. And there is a clearing house called National Clearing House at Bombay, where settlements happen there. Even though it's an electronic trade, physical settlements do happen. So you get to experience the fintech industry, some part of technology, some amount of data science, some amount of lending and borrowing, then underwriting, the applications built around that, its ecosystem, its partnerships. So that's the pros of working in a fintech space. The cons are now I will get into the cons of working in a fintech space as a support engineer. Less work-life balance, because you will be working on Saturdays, Sundays, start and end of financial year. So financial year starts on April 1st and ends on March 31st. If March 31st is an holiday, it was Saturday or Sunday, you have to work because the sales, operation, and business teams work on these days. So you will be, if you are wondering why I need to work on Saturdays or Sundays, weekends, the reason is that your sales managers or the direct sales agents, the credit underwriters, the credit managers have a target or a quota to achieve on these days. And customer doesn't have a holiday, and the loan borrowers don't see if it's Saturday or Sunday to borrow the loan. So if there is a problem with their loan application, that you need to be ready to pick up their call and troubleshoot it. So anyway, so in this world, being connected is one of the easiest boons that you get to be with. You be connected constantly to mobile phones, devices, your networks there. So everyone's expectation from these sales, credit, and operations team is that you will be ready to fix even if there is a problem on a weekend there. So that's one of the con. The second is that point number 2, we get constant phone calls from direct sales agents, sales managers, loan borrowers when a loan application gets stuck. I have already explained that the reason could be that they have reused their phone and email IDs elsewhere while creating different loan applications, because borrowers don't get the loan for the very first time they apply it. So they use different combinations of different email ID and phone numbers there, and one of the email ID was preventing from proceed of a loan application. So you need to fix that there. So, and there's a tug of war with product and technology teams. This happens because uh, technology teams wouldn't be available on a weekend, or they'll be busy with tickets, and product teams get bombarded with escalations when the technology teams doesn't doesn't action on a ticket. Tickets are raised. Tickets are a way of communicating in enterprises, in a companies there. So cleanse addresses and names for failed CIBIL or Experian pulls. This is very constant in any bank or financial institution or a lender there. So your borrowers there, taking India as an example. So any valid income tax payer's address and phone number will be present in income tax database. So this the address and phone number has to match with the one that you provided in a loan application. If it doesn't match, there's a mismatch, then the CIBIL pool will fail. So credit underwriters have progressed to, there will be, say that there are, let's say that there are 8 stages in a, from a loan application, from creating a loan application to loan dispersal, and at third or fourth stage your CIBIL pool fails. So in that case, there, when at this stage when CIBIL pool fails, there it's due to a mismatch there. So the amount of effort that has been invested by, from procuring a lead, then getting them to fill their form, getting their OTP consent to sign up for a digital loan agreement, that and to underwrite their loan application. To progress towards underwriting, you need a CIBIL pool. That's one of the data point. So when it fails there, the blame usually comes on the application or product that is being used there. So since the credit sales and operations team doesn't understand that there is a problem with the format of addresses and characters, they usually raise tickets or escalate it. So, and they are not trained to trained to cleanse that, or they don't know how to fix that. You get to do that task for them. So then the other use case is that other place where you face the fifth con is that you need to fire APIs to e-sign digital loan agreements, uh, or queue the sanction dispersals there. So what happens is that when there are, a sanction is like an object which gets created when the when the loan is about to be dispersed. So a sanction is not a dispersed loan. A sanction is an object which that the loan is approved now. It can be dispersed, and disbursements take 2 to 3 days. So when sanctions which are queued fails there, you need to re-queue the dispersal, because dispersal means that the money goes from the lender's account to borrower's account. So this was one of the very common tasks that I used to do as a support engineer at one of the fintech company. So requeuing the failed sanctions there based on certain status code, because you have been you know that borrower as a borrower that the loan has been sanctioned, but you have been waiting for dispersal. You had a you need money to uh, grow your business, or or use it for a purpose there, and but you, in spite of getting sanctioned, if the dispersal is delayed there, um, this will affect the this will make a borrower very impatient and grow angry there. So that's one of the very common use cases, that tasks that I did. Then at times there, to convert a lead is where a loan application is not yet signed up, to a sale. You need to compromise on the work ethics or a moral. This happens because I'll say there was a person A, and he had a brother A. So he had signed up with his phone number and email ID, and later his brother, he was not granted a loan. He was not loan worthy due to his CIBIL past repayments history. Now he signed up with his brother's email ID and phone number, but the but the money was lent to him. Uh, he used his brother's PAN to apply for a loan application, but the money was going to his bank account. So in this kind of case where Um, so usually you can go bend the law. You're not breaking the law, but you can bending the law. Maybe someone comes and says that this is fine, and if there is a same bank account being used for two borrowers, you can't dispute that. So then monitoring applications 20 to run 24 into 7. So 7 days a week and 24 hours a day. That's because the transactions keep happening all throughout the day and week and month of the year, because people who have paid loan will be making repayments, and uh, people who are will be borrowing the loan, they'll be making it on a Saturday, Sunday. That there is also RTGS and NEFT, which also happens on weekends there. So the applications keeps running all throughout the year, and no downtime is really causes a business impact, huge business impact. So innovation is limited by the RBI regulations and guidelines there. This is because um, financial industry is a very regulated industry in India. That so any amount of innovation has to oblige to law there. So for example, if you know that any transaction above 5,000 rupees requires an OTP, and now there is a card there. If you see now, the cards come with NFC chips there. You don't require OTP up to 2,000, 5,000. Above that, you need to give an OTP there. And say that you use the retail card, uh, local standard card, which is usable within the boundaries of India at an international merchant, say PayPal, for example, and there they can't deduct the money without an OTP there. At some banks can deduct the money, so that's where the regulations come into play, and any international merchant or the authority who is uh, debiting the funds from your account has to adhere to the RPS regulations, even though they don't have uh, they are not set up in India. That is the these are the cons of working in a fintech space as a support engineer.
Yeah. Like this is also a kind of a thing where the solution engineer also works, right? A kind of a workforce where you are part of. I think that's where it is all about, right? It's not about being a support engineer also. It's also about like how can you really get that solution in your hand. So I think the solution engineer also does the same thing. Yeah, I think probably I missed the question, but like I asked the right points itself.
So I'll do the
So
honor
yeah.
of telling about what support solution engineers does in could what is the impact that a solution engineer could make on an industry. So taking let's take Shopify as a merchant for an example there. Shopify has a lot of partners there, and there's a partner based ecosystem present there. As a Shopify partner, if I want to customize his site, you know that Shopify is a SaaS based platform. You don't need to host, you don't need to build manager infrastructure there, and not even the platform. Just you need to add your products to the cart and be ready to sell there. Shopify doesn't compete with your selling or space there. They just offer a platform there, unlike other e-commerce vendors, e-commerce companies there. So if you are a Shopify partner, you have a customer, and you need to build a site. So you know the HTML and CSS and JavaScript are the basic foundational elements that you need to make a working functional web page. So you write it, but you need to integrate the APIs with JavaScript, and there. So this kind of tasks where there is this tech that enables the sales there. So as a partner, Shopify partner, I need to uh, I need to make my customer host their products on a Shopify's platform there. So for that, I need to be able to write code. I need to be able to understand HTML, CSS, and JavaScript so that I can customize it as per their requirement there. This is where solution engineer comes into a play there. Usually they build a tooling for a product or a service, or they upsell or upgrade a new product or a service, or they craft documentation or guides for a product or a service, or they improve the perception of a product. So this is what they do. So where there isn't a ready to build, ready to consume solution, ready to consume product. Something needs to be customized there, and that requires some expertise there. This is one example of a tech space, but in different industries it could be different.
Let's just jump onto that DevOps thing that we always wanted to be through, right? I just wanted to know what are some of the fundamentals that are really required in order to be a DevOps rockstar. Like, how much should be the hard work that they need to put in, and also about like how far they need to go, because it's all about that learning, that constant learning that happens, right? That's what the industry is all about. So, what is it all about when we want to be a DevOps rockstar, and also about like what are the really good fundamentals that are really required from our side in order to be achieving that standard.
So I would say that first, to survive or thrive in this industry, so you need to collaborate before you compete there. So, so talking from purely from a job market perspective, to thrive or be successful in this industry or to contribute meaningfully, you need to know the limitations of the tooling. So, say for example, you're using a GitHub Actions or GitLab CI, where it would break, or what is the cost impact of that. So why not use this tooling? In which scenarios it would work? So I say if the team size keeps growing, how would it make a problem? So, so you see that GitLab, for example, taking GitLab as an example, GitLab has a concept of feature called local runners, where you have a Docker running there locally on your machine. Without requiring GitLab credits, you can run this, your build system. Build is nothing but a shell where scripts run, goes and executes there. You can run it locally. You can run it your local compute resources to run the GitLab build. So getting to know the limitations of the tooling is really important. So it could be similar way in with GitHub Actions or a Travis CI or a Bamboo there. So then internals of the tooling, how does the tooling work? How it is being built there? This is required because to optimize the tooling from a cost perspective, that so with the if you don't know the internals of the tooling, you'll be working against the system instead of working for the system. Say that a system means that it's a combination of different components. In a DevOps system, there is a build phase, there is a commit, where you locally commit the code, you push it, then there is a build happens, and there's a deployment happens. In all these phases are different components. If it is a Git, GitHub CI, if it is a Git that you have installed on your machine, you need to know how the Git code is internally built there. So how it would actually push it. What are the objects there? Git uses a concept of large file system, and there is a way that it tracks the objects, changes to objects there. So knowing these internal details really helps you to design systems there. Then designing systems, so that's quite essential there. Where it comes, you talk about caching, you talk about traffic shaping, you talk about security, you talk about availability, the reliability. So all system design, understanding the system design concepts is important, and implementing it is also as important as building it. So next is the network, web, and application security. So in today's world where there is systems are distributed, the threat models and attack vectors uh, are important there. How would you model your threat and attack vectors there? How would you model your threats? That's called threat model. And how do you mitigate the attack vectors? Since it's as easy as to commit your credentials to a public repository, and and this has been happening from, it's a very common problem in with very large companies too. So large corporations have financial muscle to recover the losses, but small corporations do not have it. So security plays a very understanding how to securely architect your application is also important. And last is the cost there. Cost means that you pay for an infrastructure. It could be PaaS, platform as a service, or software as a service, or infrastructure as a service. So in all this thing, how do I reduce my costs at the end of the day? Because you're paying for some service there, and because you have a need to use that service, and you have an application built around that. So saving cost is money saved is money earned. So how do you save the cost? To save the cost, you need to optimize your code, reduce its time and space complexity, use know which service to use and which when to use which service, what kind of service, which cloud provider works in which region is best. So these are some of the um, fundamentals required to be a DevOps rockstar, because DevOps means that you know the code and you also know how to operationally manage it. So there is a operations around this thing. So making your operations or making your development team not worry about the operations is the goal of the DevOps.
Yeah, that's the truth, right? We all still do operations. We all might be a developer. We just still go out and build that operations mindset, right? We still evolve based on operations we do. So now, talking about DevOps, it's also about like how do you test the applications properly. So let's just start with this question: like, what is manual testing? Because most of the time it's all about like that application going down, but the tester has a humongous role to play. So what is manual testing? Is it still relevant today in the software industry? Because what is it all about when we are talking about the manual testing completely about in a product life cycle?
So manual testing in information technology. So this means it's a process of verifying and validating a product or application by manually executing a series of steps in times where it cannot be automated. So when there is no scope for automation, or the ROI, return on investment derived from the automation, is very negligible, you 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 intend to do a manual testing process. Let's say that talking to Alexa as an example, right? You have a Echo device and there is an Alexa. So you want to understand if, as a human, does it correctly convert my speech to text? That's called as automatic speech recognition. How does its NLU model work? So if NLU means the natural language understanding. So does it actually recognize my sentences as correct utterances? In these kind of cases where you can't automate test cases, you need a human to do a task. That's where manual testing comes into play. It could also be in industry where medical healthcare industry, where you're testing uh, an ICU device, or you're testing uh, a health implant device or a health monitoring device that cannot be automated. So that's where you require a human intervention, because the amount of cognitive workload overhead is needed in achieving the task efficiently cannot be fulfilled by an automation. So it's relevant in every industry, but the question is on what kind of task is that doing. So again, it is categorized into uh, artificial intelligence, general, it's called AI, then general super intelligence, GSI, and GSI. And there is also about an AI. There's a GSI and there's a human intelligence there. So in all of these tasks, not all of them cannot be automated. So certain tasks needs manual work, and that's still relevant there.
And also like there is a lot of things like a tester's contribution is a humongous deal in a production life cycle. So what is it all about a tester's contribution in the phase of a product build, release, and the launch cycle? So how can a tester have a humongous stake in the DevOps cycle?
So um, in a typical enterprise, so the contributions of QA in the phases of product build, release, and launch cycle are, so there are certain stages there: pre-production QA, in-prod QA, UI testing, non-functional testing, and deployments there. So, so this is a hypothetical stages there, but it could differ from company to company, organization to organization, team to teams, and also between regions and countries there. So say that in pre-production QA, you have a code coverage, You have a subphase called code coverage, code review, unit testing, functional testing, and test data. So in all this comes under the pre-production QA, where you do testing, whether it's automated or manual, combination of both, before the product is even promoted to before the code is even promoted to prod. Prod means production, where your customers can directly use it. If it's in prod, that it's available for use. If it's in pre-production, it's only internal only. So in pre-production QA, you get to do these 5 tasks: code coverage, code review, unit testing, functional, and test data. You have a test data that is like a sample or a fake data you use to do testing, which resembles or closely matches with an actual data. So next, in the in-prod QA, you set up alarms and monitoring, because you have a service there. Typically now any cloud-based service, or if it's an on-prem service, you need to have alarm setup. It could be for CPU, disk, memory, or IO there, and you need to do a root cause analysis. If something breaks or fails when the code is promoted to QA, that needs a post-mortem analysis. You see why it failed, how it failed, what made it to fail, why was not this identified in pre-prod QA. You answer these questions. It's also called as correction of error. Some companies write correction of errors so that others could learn from that. And there's a test gap analysis. If the tests were not able to identify the problem, then you also analyze which are the test gaps and fill it up. Lastly, there's a testing in production. So you actually test in production. That means that you use the service that is currently running in production, and you test it, but you test with care, or your customers use it and they report bugs, and that's where that testing happens there. From my experience that I can talk about, some of the critical bugs there's a very critical edge cases gets discovered by customers even before the internal service teams discover them, and they're reported. They are fixed as early as possible, as quickly as possible, to avoid the problem to other customers. So that's how it happens in prod QA. And testing is never complete there, and it's a very ongoing process there. So there is no stop phase in testing, but you don't do load testing in production because that affects the capacity. That's the only exception. There is a UI testing where you use frameworks for different kinds of frameworks there. It could be, and you write tests there. You use the framework libraries to test, or you write test in plain vanilla JavaScript. Say, for example, in JavaScript, you use a Cypress framework or a Cucumber framework to write test to UI to see if the interactions work as that way. So you tend to use a JavaScript library to write tests, because that resembles closer to the web page functioning. And there is a compatibility testing. This is important when your product gets used by a disabled person. Say if it's a blind or a person with a limited motor or motor ability, or if he can't differentiate between colors there, then it becomes a problem for him to use your product. So big enterprises have retail accessibility teams where they test as a disabled person, and this is very unique test there, because you're making your product to also be usable for a disabled person. So you're making it more inclusive and diverse. That's about compatibility testing. This also involves on working on how does your screen or a app look on different devices there. You simulate its devices there. You use a physical or an actual device or a virtual device to test it, but usually it happens on a real device and the test gets executed on a real device, and the results comes to the tester remotely. So the next phase is non-functional testing. In this phase, there is a load, accessibility, and there is a chaos engineering. There is internationalization testing and security testing. These are non-functional components. It means that they don't directly impact the working of a product or a service, but indirectly they do. Load testing, for example, it tests the capacity. When does my service break, at which point there? So load testing branches into saturation and errors there. If you happen to know the USE method, that is utilization, saturation, error, there is a method from a famous Netflix author called Brendan Gregg. who talks about his own method called USC method, where how you find a you use a USC method to as a methodology to investigate a problem, capacity problem, the performance problem. So load testing focuses on performance there. How would my service scale when there is a billion requests, billion transactions per second? How does it scale under 10,000 transactions per second? So how does the usability, how does the utilization of CPU, memory, disk, and I/O increase linearly or exponentially or quadratically when the load increases there? That's about load testing. It's a very vital testing. There's accessibility testing. So this, I think I talked it about when I was talking about compatibility testing. It's this to make your product usable for all kinds of people, all different kinds of people with visual, motor or cognitive disabilities. There, that's about the accessibility testing. There's chaos engineering. This is a concept that existed even before Netflix released in their white paper or slides. There, this means that as a you as a you act as a monkey going and switching off your services there in production. When this happens there, and if one of the component of a application or service is switched off, does it recover automatically? Does it heal itself? This is what the chaos engineering does. That you introduce the chaos in a well working system to see how it behaves in if the chaos happened actually in a real world scenario. Um, this is again a form of reliability testing, but this is like a fault injection or a fault simulating a fault injection. There's internationalization. Internationalization means that there is a concept called I-118, which means that uh, there is a say that there is a text button buy now, for example, on a site. How does it look locally for different nations there? So if I had to see it in a Marathi, how would it look? If I had to see it in a Japanese, how would it look? If I had to see it in a Telugu, how would it look? So in different kind of languages there, how does your user interface adapt to it? Because your customers are not specific to your region. They could be from a multi-region or or a different country. So I-118 deals with uniformity of uh, languages used across languages and currencies and date formats uh, across regions and countries. Then there's security. Security means that there is a OWASP framework, top 20. There is a bunch of points there. Each there is a there is each of the points there that needs to pass the OWASP framework guidelines there. That's about security testing. So you model the threats and you build a threat model, and you based on that you define attack vectors. Then you also mitigate the attack, give mitigations about it. So in a world such as in today's world where is SaaS, PaaS, IaaS, and there is a responsibility on the cloud vendor side and there is a responsibility on the customer side. So you deviate the attack vectors and the mitigations, the responsibility of mitigation from both the sides. That's also important from a security testing perspective, because security is day one at any enterprise or a company. Last is about the deployments, which means the pipelines there. So this means that from 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 the time you commit the code to the time it gets actually deployed means that you copy the code to a server and it runs there. So what are the phases that happens there? There is a commit phase, there is a build phase, there's a test phase, and there are the different combinations. This is called as a pipeline there. Pipeline means that the code gets pushed from start from your local machine to the prod servers there. So how do you build your pipeline there? So how do you what are all the stages or the components of your pipeline? Pipeline is nothing but a generic word. So, but it could also mean a particular product or a service in a company. So this is about the deployment. Hopefully that covers all the points of QA in product build, release, and launch cycle. And QA doesn't always have to deal with testing locally. It means that he could also automate his test cases during the build phase. There, so knowing DevOps is really essential in automating the QA process or testing processes. It doesn't always have to be writing code locally somewhere and on a machine. There it could mean different things in different companies, but that depends on companies where. But usually the trend today, if you see the state of DevOps report, the trend is changing towards becoming a DevOps QA. Means that you align your QA practices towards the DevOps uh, culture
Perspective.
perspective.
Yeah,
Exactly.
I think you can mute yourself for a while because
Sure.
it's giving the echo. So now there's a quick span of trend that is happening, right? There is an API. Everybody wants to talk about APIs. Everybody wants to have a huge stake in that API market, right? Rapid APIs are there, amazing swaggers on the other side. So I wanted to know, what did you learn from the usage of public service APIs, and also what value can an API testing deliver in architecting a solution for the tomorrow's architecture that we are really designing for?
So I got exposed to use production API to one of my companies there, fintech companies. So uh, from what I've learned so far, a public-facing API need to honor its contract, also known as the API model schema. This means that whenever if you access, for example, let's say that you accessed a Twitter API. Twitter um, has a REST and SOAP architectural styles there. Architecture, REST and SOAP are popular architectural principles of building an API. SOAP as a contract that which is defined by a web services definition language, and every API needs to have a XML schema. It's also called as a model schema. So, what are its parent elements? What are its child elements? How what are the parameters? The request body, the response body, the request headers, the response headers. So, is that way of if is the API intuitive enough for a user to know it without even without getting worrying about its internals there? So if I go and use a Twitter's API to tweet on some behalf of someone, can I go and understand its input parameters and its expected responses? That's what API's model schema means. So there is a RFC for that to dictate how API should conform for it. I don't seem to know the RFC. So, but it should adhere to the REST architectural pattern there. Uh, so so and any API interfaces needs to be consistent and uniform. So the reason that I'm saying that this is needs to be consistent is that so can an end user see or find a pattern in with the usage of APIs there? So he doesn't have to be confused. And at times that while I was using a specific product there, I've seen that a lot of time certain APIs didn't have a proper documentation. Being in prod and my company was paying, we are paying to use that. So lack of documentation on API request body, header, response headers, that also contributes towards the usage of that API and adoption of that API there. So next is there is a throttling and rate limits of an API. So throttling and rate limits are imposed on any public facing API to prevent the abuse there. Because you don't want someone to. This is to differentiate between the genuine users versus the malicious users who want to DDoS your service. DDoS is a distributed denial of service. So they don't want. So in order to stop this, defining this as an attack vector, if you would like to stop this, you need to have a firewall or you need to throttle the API so that the request don't go beyond certain limit. Per second. So throttling and rate limits of an API, because it also becomes useful from a usage point of view, because you don't want to you don't want to go over the limit quota and you get 4x series errors there, because when you APIs throttle means that you don't send a response, you simply reject the request. So when the request is rejected, you get a throttle 4x series exceptions. It depends on different API providers there, but usually it's a 4x series of exceptions there. So the when a genuine request gets throttled because it went above the service quota, that's a wastage of resource. So that if you can add a back off and retry algorithm, or introduce a jitter to not throttle your API, that's a good mechanism to limit your usage. The last the last point is that DNS caching behaviors in different languages. So, for example, Java has whenever an API is there, it has a DNS name, and from the concept of networking, you would know that a DNS name would translate into an IP address, and that's called as a forward resolution. So, in a forward resolution process, certain languages cache the IP addresses. Say that IP address got changed the next moment uh, while you do a DNS resolution happens with a library, uh, with an SDK's library there. During that time, the results would be cached as IP address, and your API wouldn't work as expected, because the IP address is not being resolved to a new one. The DNS name is not being resolved to a new IP address, but the old IP address, and that's not returning any result there. It's not creating a TCP connection. So knowing the behaviors of your language is really important. Now again, it goes back to understanding the internals of your tooling. If you see the language as a tooling there, so your language, API would be used in a language, in a service or a component or an application. So knowing the internals of your language, SDK or library, helps in understanding the nitty gritties of that. For example, Java has a DNS caching mechanism. So it's called as, how does Java honor the DNS caching? If you go and read this there, there is a network address.cache.ttl, network address.cache.negative.ttl. So this can be set by a system.set property flag. At certain cases, you don't want to cache it, because you always want the network address to be translated, or the resolution to happen at all times there. You don't want to prevent a resolution. That's where your IP addresses are changing dynamically for a service there. So in these kind of cases, knowing the internals of a language SDK really helps there. So there is a lot to talk about there, but this time I think I covered my own language.
Sure. There is that evolution, right? We just go on from a tester to a developer and things like that. So I wanted to know, what was your journey, and how did you evolve from being a manual tester to the product support to the solution engineer? So how was the journey all about?
So firstly, I did a couple of odd jobs in the beginning. I was from tier 3 college doing just a BCA degree. So I couldn't get a job in a product company or my dream job there. So I had to take up the job whichever came up my way. So I after a couple of odd jobs there, uh, I took up a product tester role. So it was a manual testing role, where I used to talk to a device and listen to its utterances there. So after uh, working as a tester, then I used to lack that, I didn't have access to source code, or I never used to understand what happens in the background there. So that was the flipping point where I decided that QA is not my cup of tea. I didn't want to be limited by bounds of my job role function. Support engineering role was opened the door to acquire the new knowledge and practice it. So I switched as a product support specialist to a different company. Then before that, I had applied internally at a company X. I couldn't get it, because of my network or contacts or skills or policies. I had to switch jobs. Switching jobs led to me a role where I could be a product support specialist. It was not a fully support engineering job, but still I had I could fulfill my dreams. I could fulfill my desire to understand the technology, to understand the usage of APIs, production APIs there. So switching from manual testing to product support was the first jump that boosted my career. The next was interacting with developers there. So it says that when you go and interact with a person, you get to learn from his, get to know his learnings there. It might be a second-hand learning, second-hand experience, but still it's an experience there. So I learned even how to properly use an API there, and several times I've made mistakes while using it. I learned from my mistakes. I learned some, lost some. So at sometimes I couldn't even approach the developers. They would be busy or they would yell at me. So at least I was happy that I was getting to talk to developers, interact with developers, which was not available in my previous job. So interacting with developers was essential in understanding their applications which they had built, because the APIs were built by them. I was just an user there. So their first-hand knowledge or experience helped me in understanding the APIs there. Then reading the source code. Say for an application or service you're using, you wouldn't be able to understand end to end on how it's built, because until you build something, you don't understand it, or you build or break something. So I was neither a builder nor a breaker. Some people are good at building things, and some are good at breaking things. So I didn't have the opportunity to do either of it. So I whenever I got time, I used to read the source code. Times there I would understand something or I wouldn't understand something, but fully I couldn't understand it. But I knew that there is something going on there. How the web servers are hosted. At one of my company, they used Flask there. How is Flask being hosted on EC2 instance? How was the business process framework being hosted there? So they use a lot of servers and frameworks there, and how they integrate with each other there. When they failed, when it would fail, when it would break there, what errors you would get. So that way I grew as a support engineer there. Then taking up additional responsibility from developers there. So at times there, they would take 48 hours to work on a ticket there, because that was their tat, and their main responsibility was building or coding applications there, not to fix something. So I took up a certain additional responsibility from them, and I um, fixed a bug in a small code base, and I deployed it, made mistakes, learned from it. So that's how I grew as a support engineer. I could understand. I had deployed a Spring Boot application, and also had used it as an API there. So I could know the end-to-end process of how the API would respond when it is deployed as a Spring Boot RESTful web service. So that's how I transitioned or evolved from a product support role, from a manual tester to a support engineer.
A lot of times, like, when we are now talking about whether it's an over marketed buzzword, the cloud computing, or is the ML market that we are now talking about. So now I just wanted to know, like, is there a cloud which is still going to be in buzzword, or what was it all about when industries, and also like networking is also considered out there. So my next question would be all about, like, does networking really matter a lot as a concept in a cloud world? So there are software defined, hardware, like physical networking concepts which are coming up, right? So what is it all about when we are talking about impact that a networking concepts can build on a cloud engineer, and also about the different flavors of those things that are coming up, like the software defined network, the physical
Mhm.
networks that are coming today.
Sure. Let me share my screen. Have an important diagram to present to you.
Sure, sure.
All right. So is my slides visible? Are my slides visible?
Wait, it's not yet shared. Have you shared the screen? Like share screen?
Oh, okay, I got it. It should be
You have
visible
to
now.
click on it. Yeah, yeah. It's now
I see.
visible. Perfect, perfect.
All right, let me reshare it again. I was sharing a different screen there. Share screen, and there is a window there. Chrome tab. Okay, and now it should be visible. Yeah. So these are my slides there. So does knowing networking concepts really matter in the cloud world? So almost every cloud service offered by a cloud vendor is built on top of the physical networking components such as fibers, routers, gateways, switches, and firewalls there. But there is also another layer there. To answer this question, you need to know the differences between traditional networking and software-defined networking. So SDNs are used in the cloud, whereas the traditional networking is how the non-cloud world works. The legacy network. Say you connect to a router or switch or a gateway. So in SDN, there are three different types of planes there: control plane, data plane, and management plane. So this is not specific to any vendor or a provider there, and every vendor provider would have this kind of category classifications there. You see a control plane here and there. So I won't explain. So there's a control plane there. So I won't go into detail on explaining these terms there. But these are routing protocols there, and there's a routing table there. So and this could be a hardware component, different hardware component. There's a data plane there. There's a forwarding table. There's a packet there, incoming and outgoing packet. These are network interface cards there, but they're also virtualized there. So this is whole plane. The inclusion of control plane and data plane is being managed from a management plane. So SDN would have three planes: control, data, and management plane. And any cloud service being built would also be categorized, classified as in this way, because that's how the cloud service architectures would be built or would be designed, system designed, would be designed. So this is the SDN there. But now I'll switch the slide to traditional networking. Traditional networking would work in this way. You see a diagram towards the left. You see that, right? So before I go into the diagram, I want to share that. I would like to share that to overcome the limitations of traditional networking, SDN was born. So you can see routers, switches, and VMware ESXi servers there. This is the traditional networking era or a pre-cloud era there, and still this is relevant in on-prem networks. This is how the traditional networking in on-prem would look like. You have a router. You have a router here, R3, and there is a cloud there. There is a something in between there. There's another component which is not named. There is another router there. They're all interconnected in hybrid topology. There is a ASA, ASA1, ASA2. These are autonomous systems there. This could be combination of routers or firewalls there. There's a switch there, and usually these are called as ag routers there, or aggregate routers, which aggregate the connections or which aggregate the packets from different routers and autonomous systems. And this model is very much relevant in today's world as well. Still there are on-prem networks, and this is the way an ISP would have its network relied upon. If you have an ISP, they would have the network built up in a similar way. You see there is a software-based aggregator there, SW1 and SW2. These aggregators are called as hag routers. It could also be software-based routers there, aggregators there, and there is a access switch there, SW3 and SW4. SW means switch, and the switch. Basically, you know that there is a layer 2 switch, and switch works at layer 2. Router works at layer 3. Layer 3 means it's the IP layer, Internet Protocol layer. Switch means it's a layer 2 device. Switch is not that intelligent; it just forwards the packet looking at the MAC header there. But router knows about which network that it needs to forward the packet to. Networks are identified based on their host name, whether it belongs to a current network or a different network. Routers are more intelligent than switch because they're layer 3, but switches only know the next hop where they could switch. You see that a switch only knows the next immediate hop, which is a VMware server here, which it could forward to. But routers knows that routers can differentiate between networks based on the subnet. So they can forward it to a different autonomous system. This is called as the ASA there. This is an ASA. So, and these ASAs, autonomous systems, are managed by ISPs and a network of ISPs. It's a lobby of ISPs there who manage the autonomous systems there. So this is a traditional networking model. And still, it's relevant in today's world, and knowing this is really essential. That So these concepts, if you take up a course such as a Cisco certified ICC ND or CCI, you will get to learn these concepts. But practicing it requires that you set up your own router switches and play with it. But that's where when you get the real experience in connecting switches. These are an ideal setup would always will cost about $1,000 or $2,000 to set it up a fairly simple setup. But to experiencing it, you have to build your own lab, connect the switches, routers, break it. So that's how you get to experience traditional networking, apart from switching on, switching off your routers when a ISP stops working. So that's about traditional networking. But you see in now comparing the software defined networking versus traditional networking, you see that there is a control plane, data plane, and all these are managed individually by custom built softwares or custom built operating systems there. So they are isolated from each other, and this is how a cloud would work. But it's built on same concepts. The routing protocols are same. It uses the EIGRP, and there is a OSPF protocols there. But all of these components are virtualized, or they are being isolated from each other, so that they can be shared and scaled there. That's about the networking there. So yes, knowing the ideal traditional networking is really important even in the cloud world, because something breaks there, you need to use the same networking concepts to troubleshoot it. So in networking world, there is a important proverb that I need to say. If I tell you a TCP joke, you will get it twice, thrice. But if I tell you a UDP joke, you wouldn't get it. UDP means that the protocol itself is not reliable. It's not meant for reliability. But if I say if the TCP is a reliable protocol, and you may get the joke and twice or thrice. But if I tell you a UDP joke, you wouldn't get it at all. So because an audio or a video stream, if it's lost forever. So networking concepts really matter, whichever world that you're working on or you're going into. So still it's relevant until there, even with evolution of HTTP Web 3 and from HTTP 1.1 to 2 to HTTP 3, still it's all matters there, and nothing is going. And these concepts are not going anywhere.
Sure, perfect. And also, a lot of times when we are talking about cloud as a buzzword, right, we always wanted to just analyze where is it coming from. So, is it still an over-marketed buzzword, the cloud computing?
In a way, it's a hyper marketed buzzword. So it's essentially over marketed. But there's a lot of operational tasks which are going on in background that you're not aware of. Your cloud vendor is hiding it. So it is over marketed because every cloud vendor wants every mom and pop shop to run their applications on the cloud, because that's how that industry would thrive and it would move forward. So not every use case requires a cloud, and some mom and pop shops or some and small companies are still have on-prem data centers which are running there to deploy their applications there. So it's been marketed so much because there has been a huge growing demand in North America and European nations. North American and European nations, due to the sheer amount of workforce required, and that's not fulfilled, especially in European countries, because their main occupation there is not technology in dairy farming or food production there, and there is lack of talent that cannot be fulfilled in those nations. So this is being over marketed in India as much as possible, so that everyone gets to go here. Uh, so you usually on a service name or a product name would marked trademarked, and it's an intellectual property. But cloud is a very generic term. They would have trademarked their word, but still it's not the actual thing, that it's a marketing name that you're actually looking at it. There's a lot of tasks or events going on in background which you might even not have a clue about. There might be data center next to your building, or there in your locality you wouldn't even know it if there is a data center, because that's being hidden, and you don't have to know about it.
Sure, I think that's what it is all about, right? When industry was actually evolving, that's what we wanted to achieve. Like every single day, we wanted something to break from a cloud service vendor that we have architected it very wrong, and we just want to just bruise up some skin and just get that solution up and working at one given point of time. So yeah, I feel like serverless is not the end of it. Containers will never end in the market because it will just keep evolving. It's the same old concept which Unix had, but it's just evolved in a form of Docker, Rocket, and things like that. I think thank you so much, Bhargav. It means a lot. When such kind of an insights have been shared about networking and other concepts, all these kind of things will actually motivate us to learn a lot. And thank you so much for being part of the show.
Pleasure to be with you. Thank you, Vishwas, for hosting me. You have been really motivating to me to have my first show.
Thank you so much. Thank you so much. We'll end the broadcast, folks.